Without using a calculator, let's consider the following polynomial. F of x equals negative 2x cubed minus x squared plus 13x minus 6 to answer the following questions. What is the end behavior? So what I want you to recognize is that if you're given a question on like an MCQ, so the multiple choice portion, you may see something similar to this. Myself, this is how I think of it. I have a cubic function. That means that the end behavior, because it's an odd function and has a leading coefficient that is negative, will go in opposite directions because it's odd. But with the leading coefficient being negative, it's going to be down on the right and up on the left. What does this say? This says, as I go to the far left for x's, it's approaching positive infinity. As I go to the far right for x's, it's approaching negative infinity. Now, must you write it like that? No. But if it's multiple choice, I want you to recognize that as an option that you understand. Personally, what I would probably do, I would probably do this form that we've done all along. So, as x goes to negative infinity, as x goes to positive infinity, and we can see the function, again, as it goes to the far left, it's going up, and as it goes to the far right, it is going down. So if it's a portion in which you can just write in the answer, there's nothing wrong with doing this. Absolutely nothing wrong with that. If it's a multiple choice one, there's a great chance that you need to recognize what does this mean. Okay, let's go on to part B. If we're told that x plus 3 is a factor of the function, we want to write it in completely factored form and identify the zeros. Just as a quick reminder from earlier today, that means if it's a factor, I could take the entire function, and when I divide it by this particular factor, I'm going to get a remainder of 0. So if this is a factor, I set this equal to 0, and I solve, which gives me negative 3. And now the highest degree is 3, so the coefficient for x to the third is negative 1. For x squared, the coefficient is negative 1. For x to the first is 13. And for x to the 0 is negative 6. Now, I can already put a 0 here. And why can I do that? Because I'm told that it is a factor. We're going to drop down, and then I'm going to follow mama method. Multiply, add, and so on. Multiply to get 6, add to get 5. Multiply to get negative 15, add straight down to get negative 2. Multiply to get 6, and it does equal 0. So I just proved, in fact, that it is a factor. Now, this part you probably haven't done in several months. How can I use this remainder in order to write in factored form? So 0 equals, this has no x's, and we're going to work to the left always. This has 1x, this has 2 x's. Now, I personally don't like working with a negative leading coefficient, so right away I'm going to factor out a negative 1. So if I take a negative 1, factor out a negative 1, I'd get a positive 2x squared, a negative 5x, and a positive 2. That's because divide this by negative 1 is positive. Divide a positive 5 by negative 1 is negative. It just changes the sign. And now I want to see, can I factor this portion right here? Is this factorable? I don't have a lot of space. Hopefully you write smaller than I do, but I'm going to grab a piece of paper here. And I'm going to factor this. 2x squared minus 5x plus 2. What multiplies to give us 4 and combines to give us negative 5? That would be negative 4 and negative 1. Let's make sure. Multiplies and combines. Perfect. So most of you prefer this method since the beginning of the year. You write down the a value, you write down the c value, and then you drop down these two values, and in this case they both have an x. And I'm going to use factoring by grouping to factor this quickly. I can factor out a 2x. I'm left with x minus 2. Let's make sure I didn't make any mistakes. What times x gives us a negative x? It's a negative 1. Negative 1 times negative 2 is 2. Perfect. So they both contain an x minus 2. In the front is a 2x, and the back is a minus 1. So I was able to factor it, but in completely factored form. Remember, this is a factor, so I'm going to drop down the x plus 3, and then remember I factored out the value negative 1. So this is factored, completely factored form. Now you may recognize, if it's multiple choice, that it can be written like this, and I want you to write down both. So if I want to have just an x in front, I'm able just to take the 2 and drop it back down underneath the value to the right. This is equivalent. These two are equivalent forms. And I'll tell you why it may be to our advantage to have it in this form, because in this form right here, where I took the coefficient and dropped it back, I can easily identify all the zeros. So 1 0 is -3, 1 0 is +2, and another 0 is +1/2. Let's go back to when we first learned about polynomials freshman year. We learned there could be at most 3 zeros. Okay, we could have at most 3 zeros, and look at, we have 3 zeros. Not only that, we have 3 distinct real zeros. 3 distinct real zeros. So that's what I'd have down for this portion. Now we're going to try to graph this. So let's see what we can do. So let's go to -3 and make a dot. Let's go to +2 and +1/2. Now what else do I know here? I need to examine the end behavior I talked about up above. It says as it goes to the far left, it's going to go up. So it's going to go up on the far left, and on the far right, it's going to go down. So we're just sketching a possibly what does this look like based on the fact that we now know that we have 3 distinct zeros. By the way, what about these 3 distinct zeros? What is the multiplicity of each one? Multiplicity is 1, and you're like, Miss, I don't understand if multiplicity is 1 or 2. Watch. If I just made up a random thing, completely making this up. Completely making this up. Let's pretend this is a different function, okay? So 1, 0 is there, another is here, and another is here. I'm making this up just so you understand multiplicities. How many distinct multiplicities would this function have? 2. They have 2, because we can't repeat, right? It says 2 distinct multiplicities. What is the multiplicity at 2? 1. It's an odd multiplicity because 1 is odd. What is the multiplicity at -2? -3? 2, because there's 2 of them. So 2 of them, it's an even multiplicity. All right, gotcha. So we're going to come in something like this, and there's our graph. Do me a favor right now. If you're rewatching this or you're with me live, I'm going to press pause. I want you to give part D. I want you to give yourself a chance to try this. And then we'll talk about it, and it's important that in order to get points for this, you are able to explain your thought process. Try part D and then. Okay, so it's a cubic function, all right, so the cube being 3, it's odd, and so that means it's either up on the right and down on the left. They go up, the end behavior is on opposite directions, okay? Now how do I determine whether it's up on the right and down on the left or vice versa? It's determined by the leading coefficient. So it's because it's positive, it's up on the right and down on the left. It tells me that there is a -3 is one of the roots, or the zeros, or the x-intercepts, and it has a multiplicity of 1. That means it cuts straight through at that point. And at +2, it has a multiplicity of 2. That means it bounces off. Okay, so from these two, it's going to go down on the left. It's going to go up on the right. Now, how do I create a possible graph? Well, it has to bounce off here and just cut straight through here. So bounce off here and cut straight through. So I'm just sketching a possible graph of this polynomial function. Now we need to explain how you develop this. So I understood, based on it being cubic, and the leading coefficient being positive, I use my understanding of the end behavior to know it goes up on the right and down on the left. You want to put that in words. And you also have to use your understanding of multiplicities as they relate directly to roots to understand it's going to cut through at -3, and it's going to bounce off the x-axis at +2.